Hi, I will be discussing the test number one, which was based on Unit 1 Electricity. It was the first six classes of this course. The test starts with first question, and this question is very similar to the yellow sheet questions 11 in yellow sheet 6. So the question is, imagine you have two batteries and one light bulb. In the space below, In the space below, make two labeled circuits representing flashlight circuits, one of the flashlight to last as long as possible and the other one to have the largest brightness of the light bulb. It is okay if it does not last long. Use the standard symbols for light bulbs and batteries. So this was worth 5 points. So you have two batteries and one light bulb, right? So if you have the two batteries as like this, and this is the standard symbol for the batteries, and that is the light bulb, right? So what you're doing is you're summing up the voltage that one battery can provide. And because you have two batteries now, what is going on is that this battery voltage across these two batteries will be same as across this light bulb, right? So now you have two batteries which which are more powerful as compared to one battery. So there is more voltage across the light bulb. So because of that, the brightness of the light bulb will be more. So this is for max brightness, right? And this is a series case. And if you have those batteries parallelly connected to the light bulb like this, then that is for maximum time. And this is parallelly connected, right? So the idea is if you have just one battery and let's say one battery has voltage 3.0 and this also has 3.0, across this light bulb it is also 3.0 volts. And if you don't believe me, use the virtual circuit construction website to make a circuit like this, and you will see that if this battery is 3 volts, this is 3 volts, then across the light bulb you will also find it will be 3.0 volts. Some time ago I made a video about um, and I think this was just before the exam, about why some batteries, like you see different batteries with different sizes, but you will often see is that one battery, if that is 1.5 volt, you can find some other battery that is bigger in size but also 1.5 volt battery. So what really changes between the two? Like why do we even need thicker batteries? The answer is those thicker batteries can be thought of as two batteries which are smaller but in parallel. So the power delivering capacity, like for how long they can deliver the power, increases when you have two batteries in parallel, okay? And when you have two batteries in series, the voltages add. So what increases is the potential difference across the light bulb. So when the potential difference across the light bulb increases, it is designed for maximum brightness. When the potential remains the same, but you have two batteries, so what you're doing is the power delivering capacity, it can last longer. It can deliver the same amount of current through the light bulb, but for longer. Is that, that's what happens when you've got two batteries in parallel. And this is very similar to question 11, yellow sheet 6. Question 2 is about true and false statements. The statement number 1 is, in a parallel circuit, the voltage across each branch is the same as the source voltage. So it is true. The reason is, if you have, let's say, a battery, right? And this is kind of definition of a parallel circuit. Okay. So source voltage, let's say, is 3.0 volts. Source voltage is the voltage from the battery because that's providing you the voltage. And because when these two bulbs are in parallel, they will again they will have the same voltage across them, right? That's kind of the definition of a parallel circuit. If one Statement number two is, if one component fails, the entire circuit stop working in a series circuit, which is true. If you have a series circuit, let's say this is a series circuit I'm going to make right here. You've got a light bulb, and then a battery. So these two light bulbs are in series. If this light bulb stops working, what that means is that the current is no longer going through it. And if the current is no longer going through it, then the current is also not going through this light bulb. So in a circuit, in a series circuit, if one component fails, then the entire circuit stops working. And this is also a very similar question to you have seen multiple times when you had to design something, making sure that if you turn off one component, all the other components are not turned off. For example, you had to wire a house with different things in it, right? So it's very much like that. If you understand that, in this series circuit is not a very good choice when you're trying to do something like that, yeah, and why that is the case. So yeah, if you know this, then you will be able to answer this question. And this is discussed in activity packets, a couple of them, and also in class multiple times. So it is true that if one component fails in circuit, the entire circuit stops working. All right. Question number three is, I think it's a little tricky. Um, It says once started, a siphon will continue flowing indefinitely until the source runs dry. Okay. The answer is no, it will not. Okay. We know, like, in order for the siphon to work, there needs to be a height difference, right? Or let's say the water is going from left to right, right? The height difference should be there. But the water flow will continue to happen as long as there is some height difference, right? So it's not true that this thing will completely dry because of the siphon. It will stop. The siphon will stop as soon as the water level get decreased to a value which is same as the water level of the container to the right. So that's why third statement is false. Okay, it will not continue to flow indefinitely. It will stop as soon as those two water levels are of the same height. Statement 4 is, in a parallel circuit, the total current is equal to the sum of the currents through each branch, which is true. If you have, let's say this is the parallel circuit, right? So if you have 1 ampere coming in, so half of, let's say, will go here, half of will go here, and then it will recombine to give 1 ampere this side. Right? That's kind of the uh, the definition of parallel circuit. In parallel circuit, you've got two branches, and then it's like, it's like traffic flow. It's like flow of water in siphon, if you or flow of water in pipes. If the water comes into a place where there's divisions, there are two options to go to, and if those two options are, let's say, the same, half of will go here, half of will go here. If there's some resistance in one, then less of the water will go through that one as compared to the other one. But the idea is that if you sum total the current in the two branches, it will be equal to the current that was going in, that was coming in to that joint. So that's why this is true. Okay. In statement 5 is, in a series circuit, all components share the same current. That is true. This is a case of series circuit. So the water that goes, let me bring back that light bulb to life here. So if there's a light bulb there, whatever current is going through that light bulb goes through this one and then comes back into the battery. So this is also true. Question 3. So question 3 is very closely related to what we have seen in activity packets and yellow sheets 5 and 6, especially the one, I think it was number 5, that was the subsection was labeled as more complicated. The following circuit is, the question says, the following circuit is parallel, series, something more complicated. Explain. Most of the credit lies in the explanation of your answer. The answer is, the correct answer, it is more complicated, right? Because you cannot just say that this is a series circuit or this is a parallel circuit. I accepted any explanation um, that was along the line of this. That was along the line of, be like, oh, the current that goes through R1 gets divided into two branches, and then it goes through R4 and 5, combines back to R6, and the current that was coming through R1 gets combined back, and then you get the same current that you started from, right? Along the same line, if you have written something like that, I have given you full points. Now, there often people have also said something like, R1 is in series with this bunch, and this bunch comprises of R2 and R3 in series, but in parallel with R4, R5, R6 combination, and further R4 and R5 in parallel in series with R6 combination. That is perfectly well written answer, and I have given full points for that. If you have messed up somewhere where you said half of it but you didn't say the rest, I have taken some points off. But yeah, the answer is that it is more complicated, because if you imagine a current going in, the current goes through R1, gets divided into these two, right? So that is very much like parallel circuit. But then you have further division here, and then recombination of the current, and that current goes through R6. So R6 is in series with R4 and R5, where R4 and R5 are in parallel. This whole bunch, R4, R5, R6, and by the way, these are resistors which are named with R sub number. R4, R5, 6 combination is in parallel with R2, R3. And the whole combination R2, R3, R4, R5, R6 is in series with R1. Okay. So that is why it is more complicated, and that is the explanation of why it is more complicated. Think of, when you think of more complicated, think of a, a, a circuit that cannot be just be specified as just being parallel or just being series, but it is a combination of parallel and series. That's why it's more complicated than just series and just parallel. Question 4, it tests your knowledge of understanding of a system that seems unrelated to electricity, and that is siphon system, and how that relates to a circuit, how that relates to, um, oh, I got ahead of myself. So let's actually discuss that. That was actually question number 5. So question number 5 is siphon system and circuits. Yeah, so this tests you on your understanding of siphon system and how siphon system actually relates to circuit. So the difference in water levels in two containers is 6 inches, okay? And it results in a flow rate of 6 ounces per centimeter cube. So let's make that, like, it's a very good idea to make diagrams. So let me actually make a siphon system, and let me like just make as much things as I can. So the height difference is about 6 inches, and the flow rate is 6 ounces per cc. If this siphon system is analogous to circuit with a light bulb and a battery with current being 2 ampere and voltage of the battery being 9 volts. So if this is the case, 9-volt battery and the current is 2 ampere, what will be the current in the circuit if the height difference of the water levels is 12 inches? So if you understand in a siphon system which quantity really relates to which quantity in circuit, then you will be able to answer this question, right? So what it says is that if the height difference is 6 inches, so the height difference in siphon system is same as the voltage in the circuit, because height difference is the reason there is a flow rate in a siphon system, right? The same way battery, which is providing the potential difference, is the same reason, is the reason that we have current in the circuit, right? So if you increase the height of the height difference of the water levels in siphon system, it is as if you're gonna increase the current in the circuit. So we see that the question says that if the height difference of the water is 12 inches, that means you double the height difference. What would that correspond to in what would that correspond to in a circuit when one with one battery in a light bulb that I have drawn here? So if earlier when the height difference was 6 inches, the current was 2 amperes. Now if the height difference is 12 inches, the current will be 4 amperes because the height difference doubled, so the current will also double. So the answer for to that question is 4 amperes. I have given full credits to whoever wrote 4 amperes. I have even given partial credits to some, um, I can't really remember, but very few people who were trying to do something but were not able to get 4 ampere. Um, but if you had just written down 4 ampere, you probably got full credits. Question number 6 is the by far the most interesting one to me. It really tests your understanding of what we are trying to do here. We are trying to practice each and every day in class something called scientific method. Scientific method is basically, it's not like a something that is set in stone. The philosophy of it is basically, if you let's say you are new in this world, right, and you're an alien visiting Earth, and you see people playing chess, right, and you have to figure out what that game is about, like what are the rules of that game. So what you will do, you will see that okay, this horsey looking piece moves in certain way, this little button like piece, which is these pieces which are the smallest among all the pieces, they move in a certain way. And these big pieces, they're supposed to be important, but they don't move that much. And then one person goes one turn, the other person goes one turn, and you will see the game. And if you really carefully watch it, you can actually understand what are the rules, right? So that is basically scientific method. You observe something, right? You observe something, and you come up with some hypothesis, that is some assumptions. Okay, well, the horse moves this way, and then if that is correct, then every time someone moves a horse in a chess game, you will see the horse being moved that way, the knight being moved that way. It's the same as if you're on a mission to NASA mission to Planet X, an unexplored world and unknown life forms with unknown life forms and environmental conditions. Your team has discovered a source of water, but the safety for human consumption is uncertain. How would you apply the steps of the scientific method to determine whether water is safe to drink? Well, I mean, I found some really interesting answers, and I think almost all of you got full points on this one. That makes me happy because you understand, uh, like you have good understanding of scientific method. And this was specifically discussed in activity packet and yellow sheet, number one. I think it was like first few pages of the first activity packet. But and I have accepted any answer that was something like, oh, I'm gonna set a hypothesis. Even if you have not set a hypothesis, but you have said something like, oh, I'm gonna visually inspect it. I'm gonna look for bacterium. I'm gonna look for that. I'm gonna test it on someone else, or like test subject or something like that. I've given full point. So anything that starts with an assumption that okay this or and then the testing that assumption or testing that hypothesis, making rules about it, and then if you basically wrote something like that, then I have given you full points.